Right now, I'd like to introduce Mr. John Maneatis with True Circuits. John.
Thank you, Sean. Can everyone hear me okay? All right. Thanks for coming out this afternoon. So my name is John Maneatis, and I'm the president of True Circuits. And we are a leading provider of analog and mixed signal IP. We've been in business for quite some time. We're actually founded in 1998, believe it or not. And you guys are going too fast here. Anyway, so founded in 1998, and we've been functioning in the high-speed mixed signal analog area for the whole time. So one thing to understand about our company is that unlike other analog design companies, we've got a very big CAD focus. And that CAD focus allows us to do things that other analog IP companies can't easily do. We can create our own tools to specifically address our own design issues and address them in a very optimal way that allows us to support a wide variety of IP over many different foundry processes. And because we own all of our own tools, we can do things like run very large numbers of simulations to cover complete operating ranges of designs and know for certain that they're going to work well and not be in a situation where, because we have limited licenses, we can only cover so many design points and therefore only get limited information about how well a design will work. So in this whole CAD infrastructure that we have comprises not only a very powerful circuit characterization environment that lets us characterize designs completely and very easily, but also we have a very powerful layout environment that we use to port layout geometry from one process node to another, including even porting layout from technologies like 28 nanometer down to like 16, and do it in a designable correct way. So it's actually a difficult thing to do, but we've done it and it works very well. And we've extended this whole automation focus, not just from circuit characterization. We extend it through doing layout, front-end modeling, as well as our circuit characterization environment. Silicon characterization environment, I should say. So just to give you a little idea of our products, we've got a number of products that we've been licensing over the years. Our standard PLLs, one of our most popular designs, our clock generator PLL, which supports a very wide multiplication range, can multiply from, low megahertz, even as low as 32 kilohertz, up to, hundreds of megahertz or, few gigahertz for supporting a variety of clocking applications for digital chips. We also have other more specialized designs like spread spectrum, D-skew, and also sort of our kind of low-end general purpose PLL, which is designed to be very, very small and compact and yet deliver fairly high performance. So we also license DLLs, which are popular in a number of different applications. Traditionally, they've been used for DDR-type applications, but now they're being used for other interfaces like ONFI, as an example. And one of our newer products, our DDR5, basically we got, we realized that DLLs were very helpful to customers to create things like DDR5s, but the challenge is at these higher data rates, just was still too difficult for many customers to bear. So we decided it was time to create our own DDR5. So we've done that, and it is very flexible, very powerful. And one of the key attributes of this PHY is that it's very easy to integrate. We're not pushing any timing problems onto customers that require, a difficult set of trade-offs to close timing. We basically integrate very nicely with the controller and deliver the data over a very spatially localized interface so that timing closure is easy. And we actually close timing all the hard parts. We close timing out to the pins for you. Yet, through our delivery model, we can deal with basically any floor plan that you may have. So, and all of these designs are offered in a variety of foundries, even as old as, for some of the designs, as processes as old as 180 nanometer down to 16 nanometer. And the designs are set up to provide very low jitter. Sorry, this thing keeps clicking twice every time I click it. Very low jitter, be very process tolerant. As I mentioned before, high multiplication factors, wide output frequency ranges, small sizes, very pin programmable, which is important because that allows you to take one of these designs, license one design, pay for one design, use it for many applications on the same chip, creating all the clocks that you need for the different interfaces you may have. And we do customization as needed, and the designs are all fully documented and will support you basically through production ramp. So one of the designs I wanted to talk to you about is a new PLL design that we're now offering, which we call the Ultra PLL. And we call it the Ultra PLL because basically, we believe it's the PLL to end all PLLs. It is extremely programmable. It can, and yet also providing extremely low jitter. Sorry. So the design is capable of, so basically the design is it's a mixed analog digital architecture, and it's set up to basically give very high levels of performance, yet still in a fairly compact area and at relatively low power. It's designed to give integrated jitter as low as 500 femtoseconds, integrated from say 1 megahertz, which is perfectly adequate to drive basically any SerDes reference clock that you may have on chip. But because it supports very wide multiplication ranges from 3 up to 25,000, you can multiply from a 32 kilohertz crystal. And 32 kilohertz crystals, as you know, are dirt cheap. So being able to use one of those and one of these PLLs basically lets you create all the clocks you need on chip with a very inexpensive system. So this design is, as I said, is very programmable. It has a number of features that can make it very easy to get what you want. So one feature it has is it's a fractional end design. It has over 26 fractional bits. I say at least because depending on the frequency you're targeting, it may have more fractional bits available. But at least 10 of those are precise, and that means that you can pretty much get into the jitter floor and be able to get 200 or less than 500 femtoseconds integrated RMS jitter, doing fractional multiplication. It also supports spread spectrum with all pin programmable, so you can control the modulation depth and modulation rate, and use it for applications that require it. The design is relatively compact and low power, and as I mentioned before, it is highly programmable. So it's an ideal design for for chips that support a variety of applications because you can set it up to do whatever you want on the fly. The design is offered in TSMC Global Foundries, UMC processes, and we're offering it from 65 nanometer on to 16 and soon 10 nanometer. So if you guys have any questions, I'd be happy to answer them. Otherwise, thanks for your attention.